This is Dr. Scott Garrigan, and I'll show you how to create a simple virus spread simulation in NetLogo from scratch in 20 minutes. We're looking at the NetLogo startup screen, and we'll start by creating the interface. NetLogo traditionally starts up with two buttons, a startup button and a go button. So I clicked on the button, and we're going to call this first one Setup. That will be the command that it runs when the button is pressed, and this will be the name on the button, and click OK. A second button, so we click the button selector, click where we want the button, and this button will be called Go because it will run a Go procedure. We click the Forever link because we want it to keep going. Next, we're going to create some ways that the user can impact the variables. To do that, we will create a slider for each variable. So, clicking off to the side here, this first one will be called Population because we'll use this to set how many people are in the simulation. We can't run a simulation of virus spread with less than 2 people, so we'll start with 2 there, and put in a maximum of 300 and a starting value of 100. Easy to change as you go. Click OK. And you'll see we now have a slider where we can change the number of people in our simulation. Okay, let's create a second slider to specify how infectious the virus is. And we'll call this percent infectiousness. Sort of a shame it's such a complicated word, but that'll work. Let's start this with a value of 20, and we want a minimum of 0 infectiousness and a maximum of 100. That would be 100% totally infectious. We click OK. Next, we'll create some output so we can see how it's going. Let's create a plot, and that will be a plot of how many people are infected. Let's call this virus spread. The x-axis will just be the days passed since the virus began, and the y-axis will be the percent infected. And down here for what it will plot, let's just put percent infected. Okay. We'll be using that term later on, so make sure that it is spelled and punctuated correctly. The word plot, a space, the percent sign, and infection. No space, all lowercase. And click OK. Now I see we have a little overlap here. Well, all of these interface elements can be controlled by right-clicking or control-clicking on any one. We can select it to move it. So in this case, I'm just going to move this main window over a little bit. And similarly, we could move any of the interface elements or right-click and select Edit. And I'm going to move this one just up a mite so it's aligned. Maybe make it a little bigger. Okay, that's good. Now, in addition to the plot, let's have it give us a number for how many people are infected, the percent infected, and how many days have passed. So this reporter will report the percent infected, spelled just as we did it before, a percent sign, all lowercase, infected, and that will be the display name. And let's have it just show 1 decimal place. And a monitor to show exactly how many days have elapsed. In this case, under the reporter, it will report the number of ticks that have transpired. Ticks is the NetLogo method of timekeeping, and this will be kept in a time of days. And display name days, and 0 decimal places. We don't need half days. Okay. So we now have a completed interface. The setup button will set up the simulation. The go button will launch it and keep it going. And we can, at our leisure, however we want to, adjust the population and the infectiousness, and at the bottom we'll see results. In this black area will be where the simulation takes place. And now let's code, clicking on the code button in the top. Okay, first we'll set up a global variable, and the term for that is just globals with an S, a space, a square bracket, and this will be our %infected variable. So notice that there's only one space in there between globals and the square bracket. Our %infected has no spaces, no capital letters, and we close with a square bracket. Okay, next let's create the setup command. That starts with the word to set up. And the first thing we're going to do is a command called clear all, to clear anything on the screen, the simulation screen, that might be left over from a previous run. Next, we're going to reset the time. And the command for that is reset-ticks. Okay. So for both of those, no spaces, all lowercase, clear -all, reset-ticks. Next, we'll create our people. So that's create hyphen, and all the people and insects and cars that we create in NetLogo, the program calls turtles for historical reasons. So create turtles, and how many? Well, whatever you set the slider to be for population is the number of people that will be created. So create turtles, a space, population. Again, spelling and punctuation, capitalization is important. We're going to have three parameters, three ways that the turtles will be created, and we'll group them by putting them in square brackets. I'm just going to put one square bracket, press return, just for clarity. First, we're going to say where the turtles will appear on the screen. So each one will have an XY coordinate. We're going to set XY, but we want these to be randomly placed. So the X value will be set by random-xcor for X coordinate, and the Y value will be set for random Y core. So again, check your spelling, random-xcor, all lowercase, the same with Y core. Next, we're going to set the shape of each one of these to look like a little person. So that's set, shape, and then this has to be in quotation marks. And that's just person. Okay, double quotation marks. And that will set a shape to a little person figure that's already built into NetLogo. So make sure that it is exactly as it's typed. And we're going to start out with a healthy population. So we'll show health by the green color. So that will just be set color green. And then a close bracket. Okay. So see how I started those three commands with an open bracket, set XY, and then set shape person, set color green, and a close square bracket. Next, we're going to infect one of the turtles, one of the people. So we're going to ask the first turtle that's created, ask turtle 1, square bracket, to set its color to red, close square bracket. Okay. So red will be the indication of an infected person. Next is the longest, most complicated line, and this is one of those that we have to type. So we're going to calculate the %infected variable. Set %infected, and it's the name of our global variable that we specified in the first line. And this is a mathematical formula, so we're going to put that in parentheses. Okay. So it's just the number, the percent infected is the number who are infected over or divided by the total number of people. We get the infected number by count turtles with color. Let's put a space between color and an equal sign. Okay, so we're counting the turtles with color equal red, in other words, the infected turtles, another space, and the divided by sign, the slash, another space, and then we divide that by the total number of people, which is just count turtles. Close the parentheses. That will give us a decimal percent. To give us a simpler whole number percent, we just have to multiply that times 100. So look at that carefully. That's a long line. We are defining, we're setting the number for percent infected. We do that by saying, okay, how many are infected divided by the total number of people. And spacing and punctuation is important. And now just the word end to end that procedure. To see if we've entered it without errors, click the little green checkbox. If we did enter it without errors, we're brought to the interface screen. If it tells you there's an error, it will try to show you where it is, and we'll go back to the screen in a minute and you can compare yours to mine. But we can test the setup button. That's the only one that we have working, and you see we've randomly distributed 100 people and one of them is infected. Okay, let's go back to the code. Now, if you had an error, stop the video and correct that now. But now we can create the go command. It starts with to go, and the first command is tick, which is NetLogo's time system. That says to advance 1 day, basically. Next, we're going to tell the turtles how to move around. So we're going to ask the turtles to do something. Ask turtles. And just for clarity, I'm going to have a new line. This isn't necessary, but the turtle directions will be in a square bracket. And we're going to basically tell them to just wiggle a little bit, turn a little bit to the right, a little bit to the left in a random number, so they're all going in slightly different directions. And then for each day, they'll move forward just a step. So first we'll tell them to turn right a random number of degrees under 100. So right random 100, and that's RT is the abbreviation. LT is the abbreviation for left, so you don't have to type so much. Again, random 100. So it wiggles some number to the right, some number to the left, which will give it a random heading. And then move it one step forward, and that abbreviation is FD1. And close the bracket. Okay, take a look at that carefully because there are a lot of little spaces, little elements, a space between each element. Okay, next we're going to start infecting them. So we're going to ask the infected people, is anybody touching you who will be infected? So we ask turtles with bracket, color space equals space red, close bracket. And I just indent this a little bit. And then for those that are touching, the green turtles who are touching them, we're going to ask other turtles here. In other words, the ones that are touching them. And what we ask is if some random number is less than the infectiousness rate, then the person's infected. Holy cow. So it doesn't guarantee that a person is infected by touching the infected person. Okay. So If a random number under 100 is less than the infectiousness rate that you specified, then, and I'm just putting another line here so it's just a little easier to keep track of, then we indicate that they are infected by set color to red for that previously healthy person. And then we end with a close bracket. And I made a little error here. We need 2 brackets there. Okay. And close bracket. Okay, so notice how this is set up, and check each one carefully. We have one super easy command to add, and that's the same long one that we had in the beginning to define the infected variable. I'm just going to copy that line and paste it in here. Okay. And there's only one more new command, and that's if everybody's infected, we're going to stop the simulation. So if percent infected equals 100, meaning if 100% of the people are infected, then we're going to stop the simulation. That needs to be in square brackets, and we end with end. When you have that all typed in, click on the green checkbox, check, and if no errors show up, then we're good to go. Then we can move to the interface, and I'm just going to click Setup again. I'm going to slow the speed a little bit just because it goes pretty fast, but when I click Go, whoa! Okay, so what has happened? We've infected everybody, and at 100% infection, the simulation stops. If you look at the graph down here, we see we start off slowly, we have a really fast rate of infection, and then it took 528 days for everybody to be infected. Okay, let's just try this again. I'm going to slow it down again just a little bit so you can see it more easily. Okay, so we start off slowly as just 1 or 2 people get infected, and then once lots of people are infected, the infection proceeds rapidly until everybody's infected. So notice it's not the same number of days because of all of the random elements, which is the case in a real virus spread. Each time we run it, we'll get a slightly different number, but you've seen that it's in the 500 to 600 range, roughly. Okay, how about if we double the population to about 200? Okay. Well, if we click Setup, of course, it's more congested there. If it's more congested, will the infection proceed faster? Or because there's so many more people to infect, will it proceed more slowly? Well, you can try it. Click the Go button. And I see lots of red. And the last person finally got infected, but it only took 324 days. That's like almost half of the previous rate, isn't it? Let's just try that again. Set up and go. You can stop at any time by clicking the Go button again, and that pops the Go button out. It's like a push button that stays in. Okay, again, wow. Okay, so population density, like people at in a church service, or at a concert, a lot of people at a party or a rally can increase the spread. People tightly packed into a restaurant or a bar or a school, a gymnasium. Well, how can we change the infectiousness? One way is to wear a mask. So let's imagine that the mask reduces our infection rate to just 10, meaning when you come in contact with an infected person, now you have only a 10% chance of being infected, whereas before you had a 20% chance. Okay, let's set up and go. And if it seems to be taking a little longer, you are correct. So just by wearing a mask, we've increased the duration of how long it took for everyone to be infected by almost double. So it's like 3 years. Before, it would have taken a year or so for everybody to be infected, a year and a half. Let's try that again. Set up and go. And you can see the pattern is the same. The infection starts slowly because one person only can connect with so many people. Once half the people or a third or whatever are infected, the infection proceeds very rapidly, and then it slows down until there are only a few people who haven't been infected. And again, it's twice as long. So what can we learn from this? Well, this gives, if by wearing a mask perhaps, or by social distancing, by avoiding crowds, especially indoors, we can have twice the amount of time to develop a vaccine, let's say, or twice the amount of time to spread the message that there's a dangerous virus going around. This is a very simple simulation. It does not include things like people recovering, people developing immunity, people dying. So you now know how to create a simulation, and in the same way, you could enhance the simulation by yourself or your students to get a better feel for how this works. I hope you have an interesting time exploring the virus spread simulation and maybe enhancing it. There are several virus spread simulations on the NetLogo site, and I would encourage you to sample them. They have much greater detail and accuracy. Thank you.